When you're multiplying and dividing index expressions, there's some quick, easy rules that make it much simpler. But it's really important to understand where those rules come from so that you can apply them properly. Now, if you already know how to expand an index expression, then you're ready for this lesson. Because if we look at the multiplication first, you'll see that the rule is really simple. Now, let's take any number to use as the base. How about 2? And let's say we've got 2 to the power of, 3, and we'll multiply it by 2 to the power of something else. Let's say 4. Now, we know that if we expand this part out, we get 2 times 2 times 2. And if we expand this part out, and we're multiplying here, we're going to get 2 times 2 times 2 times 2. So this bit is here, and that bit is there. And altogether now, we've got 2 times 2 times, well, there's 7 of them, aren't there? So we can see that what that equals is 2 to the power of 7. Now, it's no coincidence that 3 plus 4 is 7. We wrote it out 3 times, then we wrote it out 4 more times. So altogether, we'd written out those 2's 7 times with multiplication signs in between them. So we can see that we need to add the numbers here. So that helps us come up with a general rule. If we just put this in general terms and say the base could be anything, let's call it A, but the rule is that the bases have to be the same. Then if we call the two indices, and they can be different numbers if they like, M and N, we know a pattern now. What we need to do is add the indices together. So we'll have M plus N. Now, some of you might think that that just got a lot more difficult because I used algebra to explain the rule, but I'm just using algebra to remind us that if the two A's are the same, obviously the bases have to be the same for this rule to work. And then whatever the indices are, we just add them together. So now we can figure out really complex problems that look hard to do, but we can easily simplify. If we've got 17 to the power of 41 and we multiply it by 17 to the power of 6, we don't need to write them all out. We know we've got 17 to the power of, what's 41 plus 6? 47. Now that's a massive number. We're not asked to evaluate it though, we're just simplifying this expression to come up with the simplest version of it. We can also work with a base that's a letter. So we could have x to the power of something, let's say 19, multiplied by x to the power of 14, and we get x to the power of, well, what's 14 plus 19? 33. And that's how this rule works. Now, the division law is really similar, but slightly different. For the division law to make sense, it's probably simplest to write it out. Let's say we've got something like, actually we'll make that a bigger number, something like this. Now, we can write a division like that, but we can also write it as 2 to the power of 6 divided by 2 to the power of 3, because we know that this fraction line means divided by, don't we? Now, if I wanted to expand out the top, then I could say, all right, that's 2 times 2 times 2 times 2 times 2 times 2. And on the bottom, I've got 2 times 2 times 2, and it looks something like that. All right, now we can say, hold on a minute, if we divide the top and the bottom by 2, the fractions should still be the same size, right? After all, I know that 2 quarters is the same thing as a half. It looks different, but I've just divided the top and the bottom by 2, and it's still the same sized fraction, it just looks different. So here, I could divide the top and bottom by 2. Now that just means I wouldn't multiply it by 2 that last time, and I could not multiply it by 2 again and again. Now each time I cross one of these out, I'm replacing it with a 1 really, aren't I? If I take 2 and I halve it, I get a 1, and a 1, and a 1, and 1 times 1 times 1 is just 1. And all of these ones I crossed out here became 1s too, really, didn't they? Now I've got 2 times 2 times 2 on the top. That's 2 cubed, or 2 to the power of 3. And on the bottom, I've just got 1. Well, if you're dividing something by 1, you really don't need to write it down. Now, what would be the shortcut here? Well, what I did is, however many 2's I had on the top, I subtracted how many 2's I had on the bottom, didn't I? So I had 6 of them up here and 3 of them down there. And once I crossed 3 of them out, top and bottom, I just had 3 altogether. So the quick method is, if the bases are the same, and they have to be the same for this to work, you just subtract the index numbers. So we can write the rule like this. as long as the bases are the same, and here again I've used the a's, the rule is you get the same base and you have to subtract the indices. So the first law we learnt was the multiplication law, and it tells us to add the indices. And the second one that we learnt was the division law, which tells us to subtract the indices. So now, of course, we could do more complicated division problems. If we have something like, let's say, 7 to the power of 12 divided by 7 to the power of, I don't know, 8. Now that's exactly the same as if it's written like this, so it doesn't matter either way. The rule says that I end up with 7 to the power of 12 minus 8, which is 4. Really easy to do. And you can do it just as easily if you're working with a pronumeral. If I had m to the power of, I don't know, 15 over m to the power of 12, then I'd say I've got m to the power of 15 minus 12, which is 3. And that's how it works.